Okay, so now that we've looked at sine and cosine graphs in some detail, let's look at the graph of, say, tangent of x. So again, I started out by just setting up a little table here. For tangent, it's nice to use multiples of pi over 4. So let me start at, say, 0 again. Okay, so remember, to compute the tangent, I divide the y by the x. So tangent of 0 is 0. Do you remember the terminal point for pi fourths? Okay, so tangent of pi fourths, if I divide root 2 over 2 by itself, the result is 1. Okay, pi halves. 1 over 0 actually does not exist. So actually tangent's kind of interesting because it actually has vertical asymptotes. Three pi fourths. Again, if I divide these, they're the same in magnitude, opposite in sign, get negative 1. Okay, you may start picking up on the pattern. Okay, do a few more anyway. Here's negative pi fourths. Okay, so if I divide there, I'll get negative 1. Negative pi halves. Okay, do you see the pattern? Because look, if I fill this in, something like that, something like that. Okay, so over here, this would be negative 3 pi fourths, right? Negative 1/4, negative 2/4, negative 3/4. That's going to be positive 1. Negative pi is going to be 0. And do you see? Okay. So there's my graph of tangent. So, need more room. At least move that. Okay. Let's see what I can do with this one. Domain. Let's put the range. That's easy. It's all real numbers. Notice the period for tangent is pi, not pi over 2. Okay, now the domain. That's the one that's kind of interesting. So how do I say this? So what I really want to say is something like all the x's where x is not an asymptote. Okay, so, well, how do I say that mathematically? So here's what I can do. I could say, let me pick one of the asymptotes, say pi over 2. Then if I'm at pi over 2, how far do I have to travel before I hit another asymptote? Each time I travel a distance of pi, I'm going to encounter another asymptote. So what if I say something like multiples of pi or pi k? Okay, now I have to say what k is. If I just write that, k could be a fraction. Then I wouldn't have a whole multiple of pi. So I have two options. I can either write k as a whole number, as in k is an integer, or I can use the shorthand to say k is an integer. K belongs to the set of integers. So there's actually really a template that I could write there. For these functions with the repeating asymptotes, if I want to write the domain, I write x such that x does not equal, and then I put the first asymptote, that was the pi over 2, and I'm not really going to have room to write this. I need to write it smaller. I'm going to write it smaller. I'm going to write the same thing again. So my template, the set of all x, where x does not equal, then I put the first asymptote, that was the pi over 2, and then I put plus, this is the distance between the asymptotes. That's where I got the pi. And then I put times k, where k is an integer. Okay, so actually this template will work for all of the problems where I need to find the domain of any of these functions where I have the repeating asymptotes. Okay, so that's a useful one to know. Should I try graphing cotangent? That's going to be similar. So again, I set up my table. Just need to think about a unit circle for reference. Let's start with 0. So the cotangent is the x over the y. So actually, cotangent has a vertical asymptote at 0. Okay, so if I divide x by y at pi fourths, I'm going to get 1. Okay, 0 over 1, 0. Three pi fourths. If I divide those guys, I get negative 1. Pi, that's going to be undefined, does not exist. Okay, so this looks similar to tangent, but flipped and shifted. Should I continue? Let's see. -1. Divide those, I get +1. See the pattern? Okay, so there I actually have 2 full periods. Erase the scratch work, and then we can write down the period, amplitude. Amplitude actually we would use for these. Amplitude is applies to a wave. But I can list, let's see, the range is easy. Period. Pi, like tangent. Domain, I'm going to use my template. This template. Useful one, right? So set of all x. X does not equal. In this case, I'd say the first asymptote is 0. Distance between the asymptotes is pi. Say k is a whole number. Okay, what about secant? Alright, so same idea. I'll need a circle for reference. Secant is 1 over the x. Okay, pi thirds. So 1 over a half is 2. So I'm going to actually change my scale then. Okay, here's pi halves. Oh, so we have vertical asymptotes again. So how do I scale this? Because the next thing I need to put on the graph is pi halves. So this is kind of interesting. I'm actually using a scale of 6. Look, 1/6, 2/6 is a third, 3/6 is a half. So you see how it is even. So look, I've got 1/6, 2/6, 3/6. This would be 4/6. 4/6 is 2/3. This would be 5/6, 6/6. Okay. 7/6, 8/6 is 4/3. Because we'll just have different colors in here. That's okay. 9/6 is 3/2. 10/6 is 5/3. This would be 11/6, and then 12/6 is 2 pi. Okay, and let's see, we could have -1/6, -2/6, -3/6, -4/6, okay, etc. So back to the table. So I had a vertical asymptote. Pi/2. Let me do some of these negative ones. -pi/3. So this is 1/2 again, it's 2. -pi/2. It's going to be another vertical asymptote. So you can kind of start to see the pattern. Okay, what about 2 pi/3? The x there is -1/2, -2, pi. 1/-1. 4 pi/3. Be -1/2, -2. Three pi/2, it's going to be another asymptote. Okay, let's do one more. So 5 pi/3. 5 pi/3 puts me back here. So this is going to be 2. 2 pi is going to be 1. So let's see, I'd have 5 pi/3, 2. 2 pi, 1. Do you see? So look, they're like these alternating parabola-ish shapes. One above and one below. So that's kind of a cool graph. Okay, should we fill in information? So for my domain, I'm using that same template. Okay, the first asymptote, pi/2. The distance between the asymptotes would be pi, right? Multiples of pi, I have to say k is an integer. The range is kind of interesting because actually with this graph stays outside of the ones. You see how the graph ends here and here? doesn't go in that interior region. So I'd actually have negative infinity to negative 1, and then 1 to infinity. Period. So the period, look, the period is not pi. The period is actually 2 pi. Because if I just showed a length of pi, I'd only have either the upright u or the downward u. Because I need one of each to establish the whole shape, the period is actually 2 pi. So notice that the period does not always match this number here, the distance between the asymptotes. Okay, so there's one more that's similar. This is cosecant. Okay, this one's going to be in sixths as well. So shall I go ahead and see? Here's 1/6, 2/6, 3/6 is a half, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. So negative a sixth, negative 2/6, negative 3/6, 4/6, negative 5/6, negative 6/6. I start with a unit circle. Okay, so cosecant of 0 is 1 over the y value. Does not exist. Okay, so I actually encounter an asymptote immediately then. Pi sixths. The y value is a half. So 1 over a half is 2. Okay, pi halves. 1 over 1 is 1. 5 pi sixths. 1 over half again, 2. See the pattern already? Pi. 1 over 0 does not exist. Seven pi sixths. So 1 over negative half, negative 2. 3 pi halves, 1 over negative 1. Okay, 11 pi sixths, 1 over negative half, negative 2. And then 2 pi, I'm back over here, defined. Okay, do you see the pattern? I mean, we could continue. And let's see, on the left, I'd have negative 2, negative 1, negative 2, asymptote, So again, these alternating U-type shapes. Just erase this scratch work. Then we'll write out the domain, etc. Okay, so all the x's, where x is not the first asymptote, 0. Distance between the asymptotes times k. K belongs to the integers. The range outside the ones. The period again is 2 pi. One above, one below. Okay, so actually you can do transformations with any of these now as your base graph. And it's the same as before. Why don't I do just one? How about one with tangent? Okay. So my base graph is going to be, well, tangent. So how do I do a rough sketch of tangent? Well, I remember a couple things. I remember the asymptotes are at the pi over 2's. And then I remember the key points are at the pi over 4's. Okay? And those correspond with 1's. So there's my rough sketch of tangent. I only have to show a full period, so that's sufficient. For step 2, I can do either of the multiplications. I can pick. I'll do the 3. So that's affecting y. Y goes to 3y. I have a vertical stretch. So that's not going to affect my asymptotes then, since those are in x. Okay, I have to multiply my y's by 3. Okay, so my point that's here at pi fourths 1 is now going to be at pi fourths 3. So if I want to keep the same scale, I can put it up here. Okay, I don't know if I want to do that. It's going to get a little big. Let's do the scale 1, 2, 3 now. I'll put the point here. 0, 0 won't move. negative pi fourths, negative 3. Try to do a better job drawing it if I can. Something like that. Okay, now I need the other multiplication, the 2. That's affecting the x. That happens opposite of what I would expect. So I actually divide the x by 2. Okay, so I'm looking at my previous graph. I'm going to divide the x by 2. So if I take, say, pi halves and divide it by 2, that's the same as multiplying it by a half, right? It's pi fourths. So my asymptote is going to now be here at pi fourths. My key point at pi fourths 3, if I divide pi fourths in half, half of a fourth is an eighth. So now that's at pi eighths 3. 0, 0 won't move. If I take negative pi fourths, divide it by 2, half of a fourth is an eighth. Half of a half is a fourth. So here's my horizontally compressed tangent graph. So what is left to do? Is there a shift? Yeah, I have to account for this plus 1. So that's outside of the whole equation. So that's going to be a shift up 1. Okay, so if I'm moving up, my asymptotes are not going to move. I kind of want to change my scale. Let me make this fourths. Have more room to write everything in. Okay, so now my point at pi eighths 3 is going to go up 1. So now it's going to be at pi eighths 4. 0, 0 is going to be at 0, 1. Negative pi eighths negative 3 is going to be at negative pi eighths negative 2. My asymptote, not going to move. And so there it is. Phew. This list. Let's see what the period is. Pi fourths to plus pi fourths, pi halves. Domain. I use my template. All the x's where x does not equal first asymptote is pi fourths. The distance between the asymptotes is pi halves times k. K is an integer.